Let's talk about exponential functions. A function of the form a to du, okay, a to du, where a is a positive constant and u is a variable, is called an exponential function. The most important function of this class is the e to the x, and many people frequently speak about e to the x as exponential functions. So what are the examples I can give you about exponential functions? If I have 2 to the power x squared, this is an exponential function. Okay, 2 to the x, 3 to the power 1 over t. Okay, I have n, as long as you have a positive constant, okay, 1.2 to the power x squared, okay, a to the x, okay. All these are exponential functions. But, we give attention to functions of the form e to the power x, e to the 2x, okay, whatever power you have, as long as it is a variable, okay, e to x squared. So many people think that these are the only exponential functions, but this is exponential, this is exponential, this is exponential, and this is exponential. As long as the base is positive and you have a variable, then that's going to be an exponential function. So how do we find derivatives of exponential functions? What we do, the easiest way is to make use of natural logarithms. Okay, let's take some time and come up with a formula. Then after, we're going to make use of the formula to differentiate exponential functions. If you have y is a to du, okay, what I can do, the easiest way of finding derivative of this function is to take natural logarithm. So, taking natural logarithms of both sides, okay, we have log base e of y is log base e of a to du. Okay, there is a law of logarithm that talks about a power of a power. Okay, a power of a power turns out to be a coefficient. So we have natural logarithm of y is the natural logarithm of a. Okay, u drops here. This is gonna be u and log base e of a. But log base e of any power can be abbreviated with ln. Okay, you can use ln or write a shortcut, not abbreviated, but we can use ln as a shortcut, okay, or as a short way of writing log base e of any function. Okay, so next we apply derivatives on both sides. Let's differentiate with respect to x. D by dx of natural logarithm of y is gonna be d by dx of u, natural logarithm of a. Okay, we say that a is a constant. A is maybe 2 or 3, whatever, is not a variable. It's u which is a variable, okay, where u is a variable and the a is a constant. Don't forget, okay? So what we have in the parentheses turns out to be something like maybe k of u, where this is a constant, and we have seen how to differentiate such functions. So we have d by dx of natural logarithm of y is d by dx of u times natural logarithm of a. So since natural logarithm of a is a constant, we only differentiate u, and we have, remember what we have just discussed, okay? We differentiate a y and we divide by, okay, y, but we are differentiating y with respect to x, so we have to emphasize this is gonna be, okay, differentiate a u, you get 1, okay, but you are differentiating a u with respect to, okay, with respect to x, then after you multiply by natural logarithm of a, okay. A is a constant, so natural logarithm of a just multiply the derivative. It's just a coefficient. So we have, when you differentiate y, you get 1. So this is 1 out of y, the y by dx is gonna be, let me write this first, natural logarithm of a times du by dx. Okay, so what's the y dx? The y dx is, when we multiply all sides by y, we're gonna have y natural logarithm of a, then du by dx. Now, what's y? Y is a to du, okay? Natural logarithm of a, then du by dx is our dy by dx, okay? So, what do we learn from this? If you have natural logarithm, if you're gonna differentiate an exponential function, I have used this result just to show you, but this is the most important step. You need the rest, okay? As long as you know the formula in this part, that's what you need the most. You may not go so much into the details of differentiation, but I wanted to show you how it comes to be. Okay, so if that's the case, then what we have to do is to look at an example. But what you have to know is, if you have an exponential function, then you're gonna write the same thing, natural logarithm of a, and then differentiate the power. Okay, if I have y is 2 to power x squared, then my dy by dx, what I do, I write it 2 to the x squared, then I write natural logarithm of the base, which is a 2, and then I go ahead and differentiate x squared. Okay, so I end up, if you check, this is 2 to the x squared natural logarithm dy by dx as, okay, 2, so 2 to the x squared, then times natural logarithm of 2, then times, okay, the derivative of x squared is 2x. And then the rest is just simplifying. So I have this as 2 to the x squared, then natural logarithm of 2 times 2x. I think I can't simplify any further than that. Okay, that's what I get when I differentiate. Suppose you have y is 3 to the power x. Then what's the y dx? The y by dx is gonna be, write 3 to the x, then natural logarithm of 3, okay, and then differentiate the power, which is x. So what do you get? This is 3 to the x times natural logarithm of 3. Since this is a 1, when you differentiate x, you get 1. Okay, if you multiply by 1, it is not going to change. And therefore, we have this as the answer. Okay, so it's all about using a formula and coming up with derivatives. Okay, if I have y is equal to, let me write, maybe I have 1.7 to power 2x. Then what's the y dx? I have the y by dx is going to be, I write 1.7 to the power 2x, then natural logarithm of the base, which is 1.7, and then after I differentiate 2x, okay, and multiply. So this is going to be 1.7 to the 2x, natural logarithm of 1.7 times a 2. Okay, that's the answer, and we are done. Okay, so we better, okay, the better way of writing it is to write this as, to first write a 2, okay, into 1.7 to the x, natural logarithm of 1.7. We don't need even the parentheses when we are multiplying functions, so I don't need to have the, I only need to write this as 2, okay, times 1.7 to the 2x, then natural logarithm of 1.7, and I'm done. That's it. Okay, so these are examples picked randomly, and therefore we can always differentiate anything. Now, what if we have e to dx? We want to differentiate e to dx, so we have y is equal to e to dx. Now, the y by dx, since this is exponential, we're going to write e to dx. Then we have natural logarithm of e, okay, because that's the base, and then we differentiate x. Okay, and if you differentiate x here, then you're going to get a 1, so this is going to be e to dx. Then natural logarithm of e is the same thing as writing log of base e of e, but we say that if the base and the power are the same, then that's a 1. So this is e to dx. When you differentiate e to dx, you end up with e to dx. Okay, what about if f of x is e to the 2x? Then what's the derivative? This will be, okay, e, write e to the 2x, then natural logarithm of e, because the base is e, and then multiply by the derivative of the power, which is a 2x, differentiate. So this is going to be e to the 2x. Natural logarithm of e is a 1, okay? Then this is a 2. So this is 2e to the 2x. Now we can come up with a conclusion when we have the base as e, okay? If y is e of any function of whatever x, c, t, whatever function, okay, then the y by dx is going to be e, the same thing, write the same thing, e to the f of x, then times the derivative of the power of x. Okay, so this is going to be, that's just a general expression. So let's work with a few examples here. I have my f of x as e to the minus x squared. Then the derivative of this function, okay, if the base is e, do not bother so much with the formula for exponential function, is get the derivative of the power, okay, and then multiply by the same expression, e to the minus x squared. So this is going to be minus 2x e to the minus x squared. If I have f of x is e to the power 1 over t, or then this becomes f of t, not f of x. Okay, I have this function f of t is e to the power 1 over t. Okay, then I write this as e t to the minus 1, and the derivative is gonna be, okay, differentiate the power, find the derivative of e to the minus 1, okay, and then multiply by the same thing, okay, t to the minus 1. So this is going to be a minus t, okay, to the minus 2, e t to the minus 1. So you have the answer. And that's all we can do about exponential functions. Then the next thing we have to do is now to look at the questions given to us. Okay, we were given a question, give x as the square root of 1 out of x to the power 5 plus 30e to the 4x. So we want to get the derivative of g of x by dx. This is going to be, I write this as the x to the minus 5, then to the half, plus 30, okay, 30 e of 4x. So what we have to do is to find the derivative of this function here, and then find the derivative of this function here. Okay, but before you go ahead to find the derivative of the function of these two functions, okay, let's try to make some more simplifications. This is x to the minus 5 over 2, okay, we're going to get the derivative plus 30 times the derivative of e to the 4x, okay. So What we said about powers of x, the power drops minus 5 over 2, x to the minus 5 over 2 minus 1 plus 30. Then we differentiate the power here. We're going to differentiate 4x, okay, and then multiply by e to the 4x. So what do we have? This is going to be a minus 5 out of 2, then x to the minus 7 over 2 plus 30. When you differentiate 4x, you get 4 e to the 4x. So what is 30 times 4? That's going to be 120. So I can write this as minus 5 out of 2, or 2.5, okay, x to the minus 7 over 2 plus 120 e to the 4x. And that's my dg by dx. That's dg dx. dg dx. dg by dx. dg by dx. Okay, that's it. That's one of the questions we had to discuss today. Okay, next question. Let me see if there's one more question. Let me write it first, then I record. So we had this question: f of x is 2x to the 4.5 plus 3x to the 3 out of 8, then plus natural logarithm of 2x was one of the questions we had to discuss today. So what's the derivative? F derivative of x is going to be get 2 and find the derivative 2 times the derivative of x to the 4.5 plus 3 times the derivative of x to the 3 out of 8, okay, then plus the derivative of natural logarithm of 2x. Okay, we know this is going to be 2 into 4.5 x to the power 4.5 minus 1 is 3.5, okay, then plus 3, this is going to be 3 out of 8, x to the power 3 over 8, 3 over 8 minus 1, then that's going to be, okay, it is 3 minus 8, which is minus 5 out of 8, then plus, okay, well, how do we find the natural logarithm, the derivative of natural logarithm? We said you get 2x, find the derivative and divide by the very function 2x, okay, so what do we have here? 2, that's 9.5 x to the 3.5, okay, plus 9 over 8 x to the minus 5 out of 8, okay. The first one here is not 9.5, it is 9. Then plus a 2 out of 2x, okay. 2 out of 2x plus 2 divided by 2x. So what do you get? You can go ahead and simplify if you want, or you can leave it at that stage. There is no problem. Okay, if you cannot simplify further, you can leave it at that. But if you think you can simplify further, go ahead and simplify. Cancel 2 and have 1 over x. So that's it. Okay, that's it. Okay, let this be our last question in the discussion we're having, or in this video. It is a product of a power of x and exponential function. Okay, there are two exponential functions. One is e to the minus 2x and one is 3 to the x. So what's the derivative of this function? Then it's going to be minus 4.3 times the derivative, okay, 1.3 plus 4 times the derivative minus 2x, okay, then plus the derivative of 3 to the x. This is a minus 4.3. If I differentiate